Welcome, everyone. Thanks for joining us. My name's Sarah Hagee. I'm the Executive Director and CEO here at the Electrical Association of Philadelphia. Today, I am joined by my colleague, Matt Dibert, as well as our presenter, Jim Hardick with Construction Sales Group, Inc., which is a 3M authorized representative for fire protection products. And this is a perfect time to have this safety presentation, given the fact that it's National Electrical Safety Month. So well done for everybody. In particular, we'd like to make sure we give a shout out and huge thanks to our friends at Billows Cooper Electric Supply for hosting and sponsoring today's session. And before we get started, as I said earlier, as you can tell, your mics are off, your cameras are off, and we've done this because we are recording today's presentation. But that doesn't mean we don't want questions. So if you do have any questions as we get towards the end of the presentation, please feel free to throw those in the chat, and we'll facilitate those questions towards the end. All right, so now, Jim, it's my pleasure to officially welcome and introduce you. Jim is a graduate of Stockton University with a BA in Sales and Marketing. Jim has been in the construction industry for the past 20 years, previously working as a superintendent and project manager for a construction company. Jim is an active member of CSI, the Construction Specifications Institute, and has previously served as the treasurer for the Philadelphia chapter. So with that, I'll let you take it away, Jim. Thank you.
Thank you, Sarah. Good afternoon, everyone. Thank you for joining us today. So I am a manufacturer's rep for 3M Fire Protection Products based out of Philadelphia. Our agency covers the Philadelphia metropolitan area, Eastern Pennsylvania out to State College, Central and Southern New Jersey, Delaware, Baltimore, and DC. Next slide, please. So today I'm here to talk to you about fire protection products for fire-rated construction. The main objective today is to provide an overview of principles of passive fire protection. We'll talk a little bit about the testing requirements for through penetration Firestop, and we'll talk a little bit about listed systems and how that could relate to your construction projects. So I want to impart a basic understanding for Firestop. We'll talk a little bit about codes. We're not going to go into a deep dive on codes. That could be an hour presentation in itself. We'll talk a little bit about the technology that the Firestop materials use, and we'll give you an opportunity to, or show you rather, how to identify some Firestop system solutions for various applications. Next slide. Okay, so what is fire stopping and why do we fire stop? Next slide. Well, we know in the US every year building fires kill more people than natural disasters and destroys billions of dollars in property. We also know that smoke travels about 120 to 420 feet per minute under normal fire conditions. And about 3/4 of all fire-related fatalities are caused by smoke inhalation and toxic gas. So basically, in the event of a fire, if there are any fatalities, chances are those people perished due to inhalation of toxic gas and smoke before they even saw the fire. So what can we do to limit the destructive power of fire in commercial building? Well, the easy answer is fire stop. Next slide. So when we're talking about Firestop, we're actually talking about a four-prong approach to fire protection. And that consists of education, detection, suppression, and containment. Education is pretty obvious. I would say you go to most commercial buildings and you look around and you can see that the fire exits are clearly marked, right? So there's signage in buildings that show us where to exit in the event of an emergency. And depending upon the size of the building and the type of building, you may also find plaques on the wall showing a map to the nearest exit point. And then, of course, we have the detection component of fire protection. These are our smoke detectors, our CO2 detectors, and these are common things that are required by code. And then, of course, we have our active fire suppression systems. We could have sprinkler systems. These could be wet or dry systems. And then last but not least, we have containment. Containment is a passive component of the fire protection equation. And when we talk about Firestop products and fire stopping in general, our whole focus is going to be on containment. Next slide, please. So what do we know? Well, we know that in most commercial buildings, the building is divided into separate compartments. Each compartment is separated by a rated floor or a rated wall assembly. So basically, the intent here is that if we can break the building into various compartments, if a fire breaks out in the building, hopefully that fire will be contained to that area, and that'll allow the occupants of the building enough time to exit safely. It'll also allow the fire department and the emergency medical response team to come in and do their job. But aside from the obvious fact of trying to contain a fire, these fire-rated floor and wall assemblies must also prevent the passage of flame, smoke, and toxic gas. Because if you remember, as I said before, most people are most fatalities happen due to smoke inhalation and toxic gas. So for a fire-rated floor and a fire-rated wall assembly to operate properly in the event of a fire, it has to be continuous. But we have one problem here is during construction, we have to cut holes in our fire-rated floor and our fire-rated wall assemblies to run electrical cable, to run plumbing, to run HVAC ductwork. So anytime we disturb a fire-rated assembly, whether it's a floor or wall, we need a means and methods to restore it back to its original intended rating. Next slide, please. Want to review some common terms in Firestop. First, I want to talk about firewalls. Firewalls extend continuously from the base of the building all the way to the roof. They're designed to remain standing even if the adjacent structure were to collapse. So when we're dealing with firewalls, we're typically talking about walls that are rated for 3 and 4 hours. So these are very robust structures. Typically, they're going to be constructed of CMU block or poured in place concrete. Next term, I want to talk about our fire barriers. These are walls that extend from the fire rated floor to another rated assembly or to a roof. These walls typically carry a fire resistance rating of about 2 to 3 hours. Typically, these walls are going to be constructed of steel studs and gypsum board, but they can also be wood frame constructed. Next slide, please. Next, I want to talk about two terms that seem to trip up a lot of contractors and even a lot of architects. That is smoke barrier and smoke partition. Oftentimes, I hear these two terms used interchangeably. They are not. Anything that's labeled as a smoke barrier has to carry a 1 hour fire rating, which is a F rating. And I'll touch on that in a couple slides here. A smoke partition, however, is non-rated. So basically, a smoke partition is just constructed to resist the passage of smoke, and it should extend from the floor up to the ceiling, provided that the ceiling is also constructed to resist the passage of smoke. Next slide. We'll talk a little bit now about fire block. Fire block is just any type of generic building material that's used in a concealed space to resist the spread of fire and hot gases. So typically, when we're talking about fire blocking materials, we could be talking about lumber, plywood, gypsum board, fiber cement board, even fiberglass bat insulation and mineral wool can be used for this application. The next term I want to talk about is draft stop. These are generic materials, and they're just intended to restrict the movement of air in concealed locations. Typically, when we're talking about draft stop, we're talking about residential construction. You don't usually see a requirement for that in commercial construction. And then last but not least, Firestop. Firestop is the passive fire protection that is used to seal round openings in between joints in fire-rated wall and floor assemblies. These are designed to maintain the fire resistance rating of the floor or wall assembly for a specified period of time. And I'll talk a little bit more about that in a couple slides here. Next slide, please. So in order to be an effective fire stop or effective fire stop system, we know that it has to prevent the passage of fire for a specified period of time but it also has to retard the transmission of heat, and it has to provide an effective smoke and toxic gas barrier. So that's why we can't just use mineral wool or fiberglass insulation when we're fire stopping, because those materials are very porous and the smoke and toxic gas can filter easily through them. And in some situations, the fire stops that we use must also be water resistant or watertight. So I'll discuss some of that a little bit later when we get into some of the testing. But basically, 3M manufactures these products, which are integral to Firestop systems. And the materials that we use for fire stopping, obviously, they're intended to stop the spread of fire, but they also must seal against smoke and toxic gas. Next slide, please. So where do we find the need for a fire stop? Basically anywhere in a commercial building, anywhere you have fire-rated floor or fire-rated wall assembly, and you have an item that penetrates through there, could be, again, could be cable, could be pipe, it could be ductwork. All those areas need to be addressed and they need to be fire stopped. Next slide. So now I want to talk a little bit about some of the testing requirements for fire stop systems. Next slide. So this is probably the most important slide in this presentation. So fire stops, when we're talking about fire stopping, we're actually talking about a system. So it's a complete tested assembly that prevents the passage of flame, smoke, and toxic gas through a penetrating item or through a joint or any other kind of weakness in a fire-rated floor or a wall assembly. And this is for a specified period of time. It could be 1, 2, 3, up to 4 hours. And the most important thing I want you to take away from this slide is that these Firestop products that I'm going to talk about later in the presentation, those products by themselves do not carry any rating. They become rated when they're used as part of a tested system or a tested assembly. Next slide. So the tested assemblies or the tested systems that I'm going to talk about, these are all tested in conformance with a ASTM test standard, and that is ASTM E814. Next slide. And the testing is carried out by independent third-party labs. The most recognizable third-party lab is UL. I'm sure everybody's familiar with it, but there are others. There's Intertech, there's FM, there's SWRI. So basically, these third-party testing agencies, their responsibility is to determine that a fire stop system will pass the criteria of the test application, ASTM E814. In addition to administering the test, they also have to document it. So they provide a listing number for each category, and each testing agency has their own nomenclature that they use to catalog all this information. Next slide. And I'll talk a little bit about that in a few slides here. But before we get into that, there's a couple more key terms I want to hit you with real quick here. We're going to talk about F rating a lot. So basically, an F rating measures the fire resistance in which flame cannot pass through an assembly for a duration of the fire test. A T rating is the length of time the unexposed surface of the assembly will not exceed 325 degrees over ambient. An L rating shows the effectiveness of a fire stop as a smoke and toxic gas barrier. And a W rating is the water resistance or the watertight seal rating for that particular material. Next slide. So what I'm going to show you here, this is the ASTM E8. Can you back up, please? The ASTM E814. So basically what we're showing you here, this is a test that was administered at UL. And basically it's a 1 hour wall assembly. So it's a gypsum wall assembly. And you'll notice on the wall assembly, there are several penetrating items. So it looks like we have, a bundle of cable. We have some insulated pipe, some plastic pipe, metal conduit. Looks like we also have a cable tray. So this is not uncommon when the Firestop manufacturers go to run one of these tests. So first they construct, the floor or wall assembly, whatever condition they're testing. And then typically they'll test multiple Firestop products in the assembly at one time. These tests are pretty expensive. They're anywhere from $10,000 to $30,000 a test. And if you fail the test, you don't get your money back. So when the manufacturers are doing these tests, they want to make pretty sure they're pretty certain that whatever they're going to test is going to work for that application. So if you would right now, if you could start the video.
1 hour gypsum wall fire test. The following video is an example of an ASTM E814 fire test. The fire test will follow the ASTM E119 time temperature curve. The wall can be constructed from steel or wood studs with the proper number of 5/8" Type X gypsum board layers on both sides of the assembly. There are several different types of penetrating items which have been fire stopped per the proper UL systems. The fire stops have been installed on both sides of the fire-rated gypsum wall assembly. You will need to fire stop both sides of a wall because you do not know which side the fire will attack from. The wall is being secured onto the furnace. The thermocouples are being placed onto the wall and the penetrating items per the ASTM E814 fire test standard. The gas valve has been turned on and the furnace has been purged. The furnace has been started. Some smoke is being seen from the penetrating items in the wall. This is a very common situation due to the combustible items which give off toxic gases. The plastic pipes, pipe insulation, and the jacketed cables are giving off smoke. You can see the severity of the fire in the furnace viewport. The temperatures at the end of a 1 hour fire test are at 1700 degrees Fahrenheit. The wall is now being removed from the furnace. The gypsum wallboard is cracked and has lost most of its structural integrity on the hot side of the assembly. The wall is taken outside and is hit with the hose stream for a predetermined amount of time per the test standard. For a 1, 2, or 3 hour fire test, the hose stream is run at 30 psi and 20 feet from the test specimen. After the fire test and hose stream, the penetrating items are inspected to see if the fire stop materials have remained intact and have not been dislodged during the hose stream test. The fire exposure side is being shown. You can see the severity of the fire and the hose stream by looking at the charring on the wood studs. the insulation and cable jacketing is burned away. You are looking at the non-fire side of the wall. The penetrations and fire stops have remained intact. To achieve an hourly F rating, there cannot be any flame promulgation through the wall or the penetration on the non-fire side of the assembly, and you must pass the hose stream test, meaning there cannot be any dislodgement of Firestop material at the penetration.
Okay, you could stop that now, Matt. All right. So that was a 1 hour test. And so the time temperature curve is basically what these furnaces are, the temperature that they're fired at. And this is based on ASTM E119. So you could see a 1 hour test, we're talking about 1700 degrees. 2 hours, it's 1850 degrees. And if we go up to a 4 hour test, we're at 2000 degrees. So we're talking some pretty substantial temperatures here. Next slide. And to put that in perspective, if we look at the melting and burning point of a few common building materials, we know that a pine 2x4 will ignite at about 700 degrees Fahrenheit. Fiberglass bat insulation, the binder will burn out of the fiberglass insulation at around 550 degrees, making the insulation very friable and fragile. And then at 1000 degrees, bat insulation will melt completely. We also know aluminum melts at around 1221 degrees Fahrenheit, and at 1100 degrees Fahrenheit, steel can lose about 40 to 50% of its strength. And at about 2200 degrees Fahrenheit, steel will yield all of its design capacity. So you can see that the test method that we subject these Firestop systems to, it's pretty severe. These temperatures are pretty extreme. Next slide, please. So we talked a little bit about why we Firestop, and we talked a little bit about the testing that's involved with these Firestop systems. So what I want to talk now is about the UL nomenclature. So basically, all of these Firestop tests are conducted by an independent third-party lab. And since UL is the most recognizable one, I'm going to focus on that now. I also want to note that probably about 95% of all of 3M's through penetration Firestop systems are UL tested systems. So that's why I'm kind of focusing on that right now. So next slide, if you would. So 3M uses a alphanumeric system to catalog all of their Firestop assemblies. And I'm just going to run through some of that. So when you look at a system drawing, you can be a little bit familiar with how they're laid out. So the first alpha component identifies the type of the assembly. So anything that begins with a C, we're dealing with a combination floor or a wall assembly. If it were an F, it would be strictly a floor assembly, and a W would be a wall assembly. Next slide. The second alpha component further identifies the construction type. So in this example here, anything with an A would signify a concrete with a minimum thickness less than or equal to 5 inches. A J signifies a concrete or masonry wall with a minimum thickness less than or equal to 8 inches. If you remember, as I mentioned before, when these manufacturers are running these tests, they will try to group together different configurations. It's a little bit more cost effective that way to do. And it makes it a little bit more easy to catalog all this information. So this example that I'm going to show you here, you'll notice that this can be used for a concrete floor or wall assembly. Next slide, please. And then the numeric component uses a sequential number to identify the penetrating item. So anything that would fall under 1000 that would be no penetrating item. So basically you would just have a large void in a concrete floor or a concrete wall assembly. Anything listed in the 1000 series, that's where you'll find metallic pipe, metallic conduit, or metallic tubing. 2000 series is our non-metallic pipe, non-metallic conduit, and non-metallic tubing. 3000 series is electrical cable. 4000 is cable trays. 5000 is insulated pipe. 6000 series would be miscellaneous electrical penetrants. This would include bus ducts. 7000 series would be your mechanical penetrations. 8000 series are your combos. So basically, in the 8000 series, you could have groupings of any combination of the items above. Next slide. So this is an example of what a UL listing or a UL system would look like. So if you go to the UL catalog and you look up the system number, or if you go to the 3M website and you search the 3M system, you're going to pull up the same exact drawing and the same exact information. So every listed system has the same components. At the top of the page, you'll always see the alphanumeric code. So you see the system drawing number CAJ 10044. Below that is the date which the test was run at UL. And then below that, it'll identify if this can be used for 1, 2, 3, or 4 hours. For this particular system that we're looking at, it lists an F rating of 2, 3, and 4 hours. And typically when they do that, there'll be a matrix somewhere in the system itself, and I'll show you that in a moment here. And then in a system drawing, so you have those items that I've just identified, and then you always have a small detail, and it'll show what the penetrating item is. It'll have a brief cutaway section of the floor or wall assembly, and it'll show a little bit about the fire stopping materials that are used. But they're always laid out the same way. So at the beginning of the system drawing, you have the identification of the assembly. It'll tell you if it's a floor or wall assembly. It'll tell you how it's constructed, what the thickness is. Sometimes sleeves are optional, sometimes they're required, and that will be clearly indicated in the text. And then it'll identify what the penetrating items are. So you'll see in paragraph number 2, it identifies what the through penetrants are. And this particular drawing, I selected it because it allows for various types of through penetrating items. It allows for a steel pipe up to 30 inches, an iron pipe up to 30 inches. It allows for rigid steel conduit up to 6 inches, EMT up to 4 inches, copper pipe, and copper tubing. If you think back to the video where they had a group of different through penetrations that were all being tested at the same time. So it's not uncommon on a system drawing to find that there are numerous through penetrating items that are allowed to be used with that particular system. Next slide, please. All right. And then at the bottom of the system drawing, it'll identify, as I had mentioned before, sometimes there's a matrix which shows the attainable hourly ratings. For this particular system, you have options for 2, 3, and 4 hour. And what it does, it tells you what the diameter of the through penetrants can be for the corresponding hourly rating. And then at the very bottom, back up one slide. Yeah, at the very bottom, it'll tell you what products can be used to fire stop that application. And it'll tell you the required thickness if you're dealing with a spray or if you're dealing with a sealant. In this case, we're dealing with a sealant. And you may find that there might be multiple products that can be used for one system. And I'll touch on that in a few slides here. Next slide, please. So what is the criteria for identifying a proper system for your project? Well, there's a couple questions you need to ask yourself and you need to identify. First and foremost, we always need to know what the required hourly rating is of the assembly. This usually will be on the life safety plans. It'll clearly indicate if we need a 1, 2, 3 hour rating, and this could be, either for a floor or for a wall application. Next, we need to understand the construction type and thickness. Are we dealing with a gypsum wall assembly, or are we dealing with a masonry wall assembly? Obviously, we need to know what the penetrating items are. We need to know the diameter of the penetrating items, and we also need to know the angular space. The angular space is the area or the gap around the penetrating item and the assembly. There's some other items that might be required too, like, do we need a sleeve? Is there a sleeve in the wall assembly that we need to address? If we're dealing with groups of cables, we need to know the percent of cable fill. If we're dealing with insulated pipe, obviously we would need to know, what type of insulation is being used and the thickness. So there are a couple common criteria that you need to identify in order to point yourself in the right direction for system selection. Next slide. So we've kind of simplified this. If you go on the 3M website and you get on the fire protection page, we have a system selection and submittal builder. And this is a screenshot from our system selection guide. So basically, it's a drop-down menu, and you can select what type of fire stop condition you're trying to address, and it'll give you some options for UL tested systems. So when I ran this particular one, I clicked on through penetrations. I identified I was looking for a certain type of cable. In this case, I was looking for systems that had armored metal clad cable in there. Next slide. And the end result took me to this system drawing. And if you remembered back from the UL nomenclature, so this particular system begins with a W, which indicates it's a wall assembly. So this is a gypsum wall assembly. And it could be either 1 or 2 hour rating. And again, these are always laid out the same way, where you have the system number at the top of the page. You have the applicable F, T, or W ratings. There'll be a little diagram showing the actual condition. And then, of course, there'll be some text describing what your wall assembly is and some of the other key components of this system. Next slide, please. And again, as I had mentioned before, it's not uncommon to have, one system drawing that addresses multiple fire stop conditions. For this example, there's several different types of cables that can be used in this assembly. And at the bottom of the page, again, it'll identify what 3M products can be used to address that fire stop condition. So probably a large percentage of our tested systems, there's going to be, more than one product that is applicable for use in that application. In this particular example, it lists 3 different types of 3M sealants. It has our IC15WB+, the CP25WB+, and the 3000 series, which is a silicone-based sealant. You're probably wondering, why do we have multiple products that will address the same condition? Each of these Firestop sealants have their own unique properties. The 3000 WT sealant, for example, it's silicone-based. So if you have a situation where you're requiring a watertight seal, that might be the product that you want to look at using. Whereas the IC15WB, it's a more cost-effective sealant to use, but it's not necessarily good for wet environments. So that's why we give you, some options when you're trying to determine what products to use. Next slide, please. So I can tell you that on just about every project I've ever been involved in, there will be a point in time in the job where we've gone through all of our listed systems and we can't find one particular drawing that addresses the field conditions. So basically, In situations where you have odd field conditions that nobody has tested to, and there's no listing or no tested system for, we have to issue what's called an engineering judgment. So basically, what 3M does, they have a staff of graduate engineers, and basically we submit whatever the odd field conditions are, and they will review it and try to match it up with our closest tested system. And then based upon that system, they'll put together instructions on how you can detail that particular application. Next slide, please. So you'll notice that our engineering judgments are laid out very similar to what the UL system drawing would look like. Then there are a couple key components that we have to capture every time we submit a request for an engineering judgment. These are project specific, so we always need to know what the project name is and the location. And then, of course, we have to identify whatever the special conditions are. So basically, any variances from the tested system will be listed here. And then following that will be the application details. It'll tell you how to address those conditions. And then it'll be based on one or more UL tested systems. And if you look towards the bottom of the page there on the left, you see this is based on 2 UL tested systems, CAJ 1044 and CAJ 1552. So that's not uncommon. I have been involved with engineering judgments where we've probably based it on 3 or 4 different tested systems. And then in the lower right-hand corner, there'll always be a number. That is the engineering judgment number. These get logged in and kept on file at 3M. So you cannot use the same engineering judgment for a different project. So suppose, 6 months down the road, you encounter the same field conditions, but it's on a different job site. You have to submit for a new engineering judgment request. And although we'll probably issue the same instructions on how to detail that, we have to go through the process of documenting all this, and it has to be specific for that job site. Next slide. Okay, so far we've talked a little bit about why we Firestop. We talked a little bit about the testing requirements, and we also talked about how all that stuff gets documented with the third-party testing agency. Now I want to talk a little bit about some of the technologies that the Firestop materials use, and we'll talk a little bit about products and some applications. Next slide. So 3M is a full-line Firestop manufacturer, so they make a bunch of different products that can be used for fire stopping applications. So obviously we have the sealants, but we also have pillows. We have mechanical pass-through devices. We have fire blocks and plugs, cast-in devices, fire-rated foam, putty pads, and endothermic mats. And I'll talk a little bit about those products now. Next slide. But before I get into it, I just wanted to go through basically all the Firestop products are broken down into 4 distinct categories, and those categories are based upon the Firestop technology that those materials utilize. They are insulative, intumescent, endothermic, and ablative. So basically, the insulative products, these are basically a non-combustible material that we use to protect fire from spreading to combustible materials. Anything that falls into the intumescent category, intumescent materials, when they're exposed to high temperature or fire, they produce a very durable char. So basically, they expand and increase in volume. Anything that relies on endothermic technology, endothermic technology relies on chemically bound water. So basically, that material has water in it, and when it heats up, it releases water molecules, creates steam, and that steam creates a cooling effect on the surface, and it stops the material from burning. And then the last category is ablative. So basically, ablative materials use some type of product that has a very high burnout temperature. Typically, ablative materials are silicone-based. Next slide. but probably the most widely used and recognized fire step technology is intumescent technology. And probably the large percent of the fire stopping scenarios that you'll encounter on your job site will probably require an intumescent type fire stop material. Next slide. As I'd mentioned before, 3M manufactures a few different types of fire stop sealants. The CP25WB is our workhorse of the product line. It is an intumescent sealant. We have more UL tested systems with this sealant than any other sealants in our product line. It's available in a couple different packaging sizes. It's available in the sausage packs and of course pails and tubes as well. This product, we have tested systems up to 4 hours. And if you're working on any projects that require LEED certification, we do have some credit points that you can qualify for with this product. Next slide. The next product I want to discuss here is our FIP foam. This is a 2-component urethane foam. So basically, when this material is dispensed, it expands about 5 times in volume. It's a great product to use for applications where you have limited access, or if you have a group of cables that are tightly, bundled together because of the expansive nature of the material. It kind of fills all the voids very well. We have tested systems with this product for up to 2 hours. This is a 2-component material, so it does require a special application tool. We have a pneumatic dispensing gun that we use, and it gets dispersed through a static mixing tube. I want to take a moment here to recognize that not all foam products are created equal. This is a very unique product. It's nothing like the foam in a can that you would buy off the shelf in a big box. Those materials are highly flammable. This is specifically designed and tested as a fire stop material. Next slide, please. So again, some of the applications for the FIP one-step foam. It's a great product to use on cable trays or anywhere where you have bundled cables. And again, because the material expands and increases in volume, we typically don't require any backing material behind it, so you don't need to use mineral wool or any type of backing material. Next slide. So the next product here is our fire barrier blocks, plugs, and planks. So what we've done here, we've taken that 2-component urethane foam and we've basically pre-manufactured it into various shapes. So if you have a situation where maybe you don't feel comfortable using the dispensing tool in the field and using the FIP foam, you can buy these materials already prefabricated. The nice thing about the fire barrier blocks and plugs, it's a pretty economical way to close down a large opening. They're reusable and you can penetrate these pretty easily. So if you had a situation where you're using a plug and you had some cable going through it and you want to run some more cable, you could simply take an insulation knife and slit it, pull your cable through there, and then you can seal it with the FIP foam or one of our other approved fire stop sealants. Next slide. They're available in a couple different sizes and shapes, as you can see there. The next product I want to talk about, the Firestop pillows. The pillows are a highly intumescent wafer that is sandwiched between mineral wool. So there's multiple layers of this intumescent wafer material and this mineral wool, and they are self-contained in a plastic wrap. It's available in 2 forms. Basically, we have it with Velcro on it, so you can interlock the components together, and we have it without the Velcro strips. We have 3 sizes for the pillows. There's a small, medium, and large. And again, these can be used for, where you have situations where you have multiple penetrating items, or if you have cable and conduit or cable trays. They are reusable and there's no expiration date on these products. So You can store them for quite some time before they're actually put into use. Next slide. Next up is our pass-through device. This is a mechanical device. So basically it's a metal body with a hinge, and inside the material is a intumescent material. They're available in square, round shapes and in a few different sizes. They can be ganged together if you have a situation where you have multiple penetrating items. And the nice thing about this product, again, it's a pretty clean installation. And it can also be used for cable management. Next slide. Here's an example of an installation guide. As with all of the 3M fire protection products, we have installation guides available. They're typically set up in the same format where, it's a pictorial, minimal text on there. So, the intent here is that if you had, multilingual trade force and they were trying to determine how to install this, they could pretty easily just look at the picture and get a general idea on how this material would get installed. The pass-through devices, we have a few different hourly ratings available, so we have a few different tested configurations for this product as well. Next slide. This next product is called our cast-in device. It's a one-piece plastic assembly that has a intumescent material in it. So basically, these get cast in concrete floors, or they could be used in concrete walls as well. So basically, you attach the plastic body to your formwork, whether it's a wood or metal form or a fluted metal deck, and then you pour your concrete around it. There's a cap on the top side to keep the concrete from entering the device, and there's also a seal on the bottom side. So they are sorry, I lost my train of thought there. So basically what you would do, once the concrete was formed and you're ready to pull whatever the penetrating item is, you simply take the cap off, you pull it through there, and you're done. There's no other additional Firestop material required. Next slide. And we also manufacture a plastic wing that can be attached to the cast-in device. So if you have a situation where you have a fluted metal deck, the wing is intended to span the flutes of the deck. And you'll notice on the right-hand side of the picture there's an example of our system drawing. And again, if you think back to the UL alphanumeric code, you'll notice that that begins with an F, which indicates a floor assembly. And that's exactly what you're seeing there. It's a concrete poured over a metal fluted deck with the cast-in device and a bunch of different cables being pulled through it. Next slide. Next product I want to talk about is our moldable putty. So this is available in putty pads, and we also have it in a bulk format as well. We have tested systems for up to 4 hours with our putty. The putty is a great product too. It remains flexible. It's good for retrofit applications. Probably use the most putty for applications around electrical boxes and outlet boxes. Next slide. And just without getting into a whole lot of code detail right now, but basically, if you have steel outlet boxes that exceed 16 square inches, or if you have a situation where you have over 100 square inches of opening in any 100 square feet of wall section, you're required to protect those outlet boxes. And the way you can do this is by using a putty pad. Also, if you have outlet boxes on the opposite side of the wall, and they are separated than less than 24 inches, you have to use a putty pad or some other type of fire protection on those items as well. Next slide. So here's an example of a job where there were multiple outlet boxes, and basically we had over 100 square inches and 100 square feet of wall. So all of those outlet boxes would require a putty pad or some other type of protection on the backside. Next slide. And again, we have installation instructions for the putty pads as seen here. Next slide. Composite sheet. Composite sheet, what that is, it's an intumescent material that has a galvanized steel plate on one side and a foil scrim on the other. Again, this is a cost-effective way to close down large openings in fire-rated floor and wall assemblies. Typically, we use these a lot of times where we have multiple conduit or if we have cable trays. And the best way to install this is you have your rough opening, you attach this to your surface if it's the floor or wall, and then you go back with your saw, your core saw, and you cut your openings and pull whatever the penetrating item is through that. Next slide. And again, there's just a little bit more information on the composite sheet. It's available in multiple sizes. It's again, it's a cost-effective way to close down and address large openings in a fire-rated assembly. Next slide. So we talked a lot about intumescent technology, and we kind of focused on that because the large percent of our tested systems use a intumescent type product. The next product I want to talk about now is endothermic technology. And as I mentioned before, endothermic materials rely on chemically bound water. And there's one common building material that's in just about every commercial construction product that relies on endothermic technology, and that would be gypsum board. So there's usually up to about 19% chemically bound water by volume in gypsum. So that's why we're able to use gypsum in fire-rated assemblies. So if you remember back to the video I showed you, in the event of a fire, the paper facer burns off pretty quickly from the gypsum. And once that raw gypsum is exposed, all that chemically bound water, all those water molecules are released, and it mitigates the fire on the surface. Next slide. So the product that we have that relies on endothermic technology is called Interam Endothermic Mat, or as we affectionately call it, EMAT. This can be used for several different applications. It can be used to protect the conduit, can be used to wrap cable trays. Sometimes we use it on the back of electrified panel boxes, and it can also be used to protect structural steel. Next slide. So there's an example of two of our listed systems using the EMAT material. If you recall, most of the tested systems we've talked about were all UL. These happen to be Intertech listings, and they're laid out very similar to what you would find in a UL system design, where you have your design number up top, you have the date when the test was administered, and then you have the information about the product and the application. Next slide. There's a couple more examples of where EMAT can be used. We can use it on the backside of electrified panels. Sometimes it's used for the valve boxes in wall assemblies or an elevator call box. Next slide. So as we come to the conclusion of the presentation now, 3M has over 800 UL tested Firestop systems. As I had mentioned, we have a complete line of Firestop products, which includes sealants, wraps, foams, pillows, pass-through devices, and composite sheets. Some of the things that I can provide, me and my counterparts, we do certification training, we can provide field support, and we also can prepare projects submittal packages. Excuse me. And of course, 3M has the staff of engineers that can assist with the engineering judgments. Next slide. We also have a pretty comprehensive library of YouTube videos showing you how to install the various Firestop materials. Next slide. And we also have specific YouTube videos for some UL listed systems. So basically it shows you, the particular UL system design and how you would install that Firestop material for that application. So that concludes the presentation. If I can be of assistance in any way, please feel free to reach out to me. And thanks again for giving me the opportunity to talk to you today.
Thank you. Appreciate the time. That was a great presentation.
Thank you.
Matt, I think we have at least one question in the chat. Matt, you're on mute, my friend.
We do have a question in the chat. How do you remove the foam from a cable tray when you want to add more cable?
For the foam product, it's a urethane, so it's going to have a tenacious bond to just about any surface. So you wouldn't remove it. You would simply just cut a hole in it and pull the cable through the foam, and then you could seal around it with some more foam. So the cured foam will bond to the wet foam very well. Urethanes have a tendency to bond to themselves very well.
Okay, great. Thank you. Well, I will say to everyone here, number one, thank you for your time. We did record this. We are still waiting on approval to be able to share it. But in the meantime, what we will make sure is everyone who is here has Jim's information, because clearly he and his team can provide a lot of technical services around some of these solutions. So again, Jim, thank you so much for your time. Great
You're welcome. Thank you.
presentation. We'll got to get you in person next. So
Yeah.
yeah, good deal. All right, everyone. Thank you so much for joining us and have a great day.